So, common grounds, right, Keith?
Yes,
That's just
common ground.
bit us in the ass for like 2 hours.
Yes, must have common ground.
So, green power is 12 volt. Red power is 5 volt. The 5 volt bus powers the microcontroller and the NAND gate. The green power bus powers the lamp, and it is hooked up to the collectors of both NPN transistors. The emitters are set up in an emitter-Fowler pair like a Darlington transistor. The light bulb is from VDD, which is 12 volts, or the green voltage bus, into the collector of the final of the Darlington pair. The emitter is tied to ground. When the MCU pin goes high, it comes into the NAND gate, and it's compared on the AND part with VCC, which is also high. The NAND changes that signal to a low or a 0, which gets fed into the base of the first of the pair of transistors in the Darlington configuration, which when the MCU is on and VCC is on, it turns the bulb off and this LED goes on. When the MCU pin is off, the LED is off and the light goes on. So this setup works by allowing the default configuration to just turn the power on for the brake light, basically. So if it fails in any way, the circuit fails in any way, the brake light will go on when the brake pedal is pressed. And then if this is working, then the MCU will be able to flash by turning the light off.
Yes.
And then we can base that off of the acceleration values from the accelerometer.
Yes.
The circuit diagram is over there with the truth table for the output of the circuit. So again, when the MCU is on, MCU pin is on, VCC is on, the AND is a positive, and the NOT on the end of the NAND gate will negate that and make it an off. When the MCU pin is off, which will be the default way that this would happen if the MCU messes up or the circuit's off, VCC is on, the AND would be an off because it doesn't have both legs as a 1, which would invert the signal at the NOT to be an on, leaving the brake light on. And 2 hours worth of us not having a common ground. Common ground. Oh,
Best find it.
the signals look like this. So the yellow line is actually the MCU pin on. The blue line, which is attached to the green probe, is the output of the NAND gate. So again, proof on the scope that when the pin from the MCU high, power going to the light bulb is off, and when the MCU pin is off, power's high. So I'm going to sketch this. I'll sketch this down on my notepad. I've already got the truth table and stuff, so later I'll be able to just, this part we'll have to, we only need 1 pin to power this part, and then we either need 3 more pins for SPI or 2 pins for I2C.
2 pins for I2C is fine. That's how I've been using the current demo unit.
Right, but we don't need that good of a accelerometer. Okay, you can